on the coding train. Welcome back to another Beginner's Guide to Machine Learning video. Today, I am very excited to look at the FaceMesh model in ml5.js. Now, there are endless possibilities in terms of what kinds of creative applications you can do with the FaceMesh model. I'm just going to show you in this video some key starting points in terms of how to get all of those face landmarks, how to work with different subsections of the face, whether it might be the lips, eyes, etc. And then finally, I want to look at how you can start to render the geometry of the face. What does it mean to draw triangles covering that mesh, color those triangles individually, as well as texture and image onto those triangles, which allows for all kinds of masks that you might overlay on top of a face. Now, if you were watching my previous video about the handpose model closely, you might have noticed in this blog post that I referenced, there is also a discussion about tracking key points on a face. This post is great background reading for everything about how this particular model works, as well as this paper published in 2019. With any of these tracking models, it's important to be thoughtful about how you're using them. I would say that whenever you're tracking points on a person's face, that's a reason to be extra sensitive with all of the privacy and surveillance implications that come with face detection and face tracking. While the paper does provide some details around the data set that we use for training, it says it used 30,000 in the wild mobile camera photos. There's unfortunately very little information that I can find about where those photos were sourced from and what kinds of permissions are associated with using those images. I was pleased to find a model card with this FaceMesh detector. A model card is something that's typically produced with a machine learning model to provide details around its intended use, as well as all of the data around evaluation and testing of the model. There's some information about the limitations, a bit more detail around the dataset images that were used for training, as well as the fairness evaluations they performed. This is not actually the first time that I have looked at this FaceMesh model on this channel. You might remember the collaboration I did with Pat Vera, where she created an interactive visualization controlled by the face. Incidentally, Pat has been making lots of other ML5 tutorials on her channel, and I encourage you to check those out. I also want to point you again to the demos from Jack B. Do. Here is a mouth-controlled synthesizer. As a first step, I'm going to begin with the code from my hand pose video and just change it from drawing all of these points on my hands to all of the key points on my face. One thing you're going to notice is that with body pose, there were 17 or 33 key points on the body, depending on which model you used. With hand pose, each hand includes 21 points. The FaceMesh model includes 468 points on the face. So it's going to be a much larger amount of data to work with. Let me first just rename all the variables from hand pose to FaceMesh. So let me just remind you of the bigger points here. There's a variable to hold on to the FaceMesh model. There's an array to keep track of the faces that are detected. Create capture is used to open a feed from the camera. Then I call detect start with the FaceMesh model on the video. And then as long as there is a face detected, I loop through all of the faces and all of the key points and draw a circle for each one. But it's still just my hands, because even though I named everything FaceMesh faces, I'm still loading the hand pose model. Let's now change that to FaceMesh. And there we go. Suddenly, I have all of the points on the face. Now I'm drawing those circles quite large. Let's make them smaller. There it is, all 468 points. Now, the FaceMesh model can detect more than one face. So if a second person came in, we'd see the points on both faces. However, I know that during this demonstration, I just want to work with one face. So I can actually add a modifier property to the FaceMesh function saying max faces 1. Not a critical detail here. Maybe it helps make sure I don't make some errors in the future. Maybe it helps the model run faster if it's only looking for one face. Mostly I'm showing this to you because when you're working with an ML5 model, you'll want to check the documentation page and see what types of properties can be passed in to the model loading function. I'm also noticing there's a little redundancy here. I don't actually have to check to make sure the length is greater than 0, since I'm only drawing the faces if they exist. Okay, so the first question I'm imagining you're wondering is, how do I know which point is which? What can I do with this? This model comes with a diagram that shows all of the key points and their index into the array. And in fact, I can zoom way in and see, for example, that this point in the center of my nose is index 19. Let's double check that. Instead of looping through all the points, I can just get that single key point at index 19 and draw just that one. Let's make that dot a little bit bigger. And there you go. Now, is it overkill to use the entire FaceMesh model just to draw a single dot? Maybe, but I wanted to show you that you can individually address these points for any kind of overlay or analysis that you might want to do. Let's take a look at all of the data that comes in from the FaceMesh model. Again, I have a mouse pressed function here where if I click, it's going to console log the results. So first thing you'll notice, key points, an array of 468 key points. Then ML5 takes that larger key points array and divides it up into different parts of the face. So for example, if I only wanted to work with my left eyebrow, I could iterate over those key points. I can say L eyebrow equals face dot left eyebrow. Let's go back to iterating over all the key points. But instead of the entire face, let's just iterate over the key points of the left eyebrow. I'm so used to programming with camel case that I'm capitalizing the B, which is not correct. Let me just write out the whole word, left eyebrow. And then this is my, wait a second here. This is my right eyebrow. I think this is because I've flipped the video image. And so the model doesn't actually know that my face is flipped, so it thinks this is the left eyebrow. Yeah, so if I don't mirror the video, then this is my left eyebrow. This is just something to be aware of as long as you're consistent in how you're using them. Let's switch to the lips. Okay, all of the key points on the lips. Now, if you remember in Jack's demonstration, the lips were drawn with a continuous line that followed the contour of the shape. Let's try to reproduce that effect. I can start with begin shape and end shape. And then instead of drawing a circle at each point, I can set a vertex at each point. Okay, I've kind of got this Pac-Man style mouth. Well, let's change from a fill to a stroke. So while ML5 did do the work of helping me find only the key points for the lips, in this case, I might want to have a separate list of the outer key points and the inner key points of the lips. This is where you might need to start to analyze the diagram yourself and build your own lists, depending on what you're trying to do. In this case, because I have access to Jack's demo, I could go and find the list that he's using there. So here we have a nice strategy, which is to create arrays that include an ordered list of the index values that you want along that FaceMesh pattern. So I've pasted them in here, and instead of now relying on the object that's inside of the results from the model, I can pull the index points from these pre-made hard-coded lists. Let's do the exterior first. Now the index is not coming from the counter, it's coming from the lips exterior array. Then I want to pass that index into the key points array. But I have an error. That's because these landmark indices are for the entire array of 468 points, not the subset of the lips. There you go. Now that's just the outer perimeter of the lips. But I can add the close argument to end shape so that it closes. Here's a slightly thicker stroke just so it's easier to see. Let's add the inner lips now. And there we go. Now I have two separate contours, one for the outer lips and one for the inner lips. What if I want to control something based on whether my mouth is open or closed? Well, I could pick just 2 points and calculate the distance between them. Let's try the distance between points 13 and 14, which are right next to each other when the mouth is closed. There, looks like I picked the right points. So that distance could control the frequency of sound, as in Jack's demo. Maybe just as a simple solution here, let's just put a dot on the nose that grows and shrinks based on when I open and close my mouth. Let's go back to key point 19. And now, as I open and close my mouth, you can see that the point on my nose is growing and shrinking. Maybe instead of a mapping, you could actually use a threshold. So when you open your mouth a certain amount, bring in a particle system and bubbles float out. I should also note that these are in raw pixel dimensions. So that value, the range of that value is going to be different whether your face is closer or further away from the camera, but certainly you could normalize them according to the bounding box of the face. Speaking of which, let's look at that bounding box. It's right here under the box property. Now, the values I'm getting are actually for the corners of the box, not the center. But X-min and Y-min with the width and height is exactly how I would draw a box in P5. Now, there you can see I'm getting the bounding box of the face. This could allow me to normalize the points according to that bounding box. I can also do some things like maybe draw the video with my face always in the center. So to do that, I need the center of the canvas. Then I need the offset of the center to where the face is. And then what if I translate by that offset? Hold on a second. Let's draw the box after the translate. Oh, I'm drawing it from the corner. So I really need to offset from the center of the box. Now, that face is always in the center, but I could also draw the video with that offset. Whoa. All right, this is weird. The green background isn't doing me any favors here. Well, let's draw a background. Now, it's very jittery. I wonder why that is. I'll add a little bit of smoothing. This is not too dissimilar to like a Steadicam or camera stabilizer effect. Instead of setting the translation to the raw offset from the values that I'm getting from the model at any instant moment, I'm now smoothing those values with the lerp function, only moving 5% of the way towards that offset with every frame. So that covers the raw data in terms of the key points and parts and bounding boxes of the face. But what about this idea of a mesh? What is a mesh? Let's say I have a collection of points, just like I do with the FaceMesh model. My examples so far have treated these as individual points, but I could create a triangulation out of these points. What do I mean by that? What if I connect all of the points with lines, making sure that none of those lines cross over with each other? I might get something that looks like this. Now, this is what's known as a Delaunay triangulation. I've talked about this particular kind of triangulation in more detail in my weighted Voronoi stippling coding challenge. The math behind this triangulation is not important because with the FaceMesh model, there is a pre-selected, pre-designed set of triangles. And what I want to be able to do is, instead of rendering just simple dots over the face, what if I were able to fill the particular triangles of the mesh that is the face with different colors? In order to do that, I would need to know if these are the index values for these vertices, 0, 1, 2, 3, 4, I would need to have collections of which points make up the triangles. For example, 0, 1, 4, 1, 4, 2, 2, 3, 4, 0, 4, 3. ML5 has a function called getTriangles, which will provide to you a list of groups of 3 of all of the index values of the key points in the FaceMesh model. Let's look at how that works. Now I'm back at the original example of just rendering all the key points. Let's call getTriangles. I'm going to do it in setup and just have triangles as a global variable. I think that's the easiest way to work with it. And there we go. You can see, even though there are 468 points, there are 852 triangles. Each triangle is made up of 3 index values to the key points array. How do I draw those triangles? Now, instead of iterating over the key points, I want to iterate over the triangles. I can look at each individual triangle. Each individual triangle is an array of 3 numbers. Let me pull those out into 3 variables. Oh, I've done something terrible. There's a function in P5 to draw a triangle called triangle, so I really shouldn't use that variable name. Let's just call it try. And I've done something rather unusual here. Normally, I might just write something like let A equal try index 0, let B equal try index 1, C try index 2. But this is something that's called object or array destructuring. I can actually make a little mini array of variable names and pull out those 3 values into 3 individual variables. This allows me to now get the 3 key points that I want. They are each associated with the index into the larger key points array. Then I can draw a triangle. Rather than use the triangle function, I'll use begin shape and end shape. Let's remove all the circles. And there you go. Now you can see all of the triangles drawn over the face. Rather than a separate call to begin shape and end shape for every single triangle, it actually makes more sense for me to put begin shape and end shape outside of the loop and pass in the triangles argument. This tells P5, hey, I'm going to give you just collections of 3 points, make triangles out of all of them. Let's stop drawing the video. What happens if I were to now fill all of these triangles with a particular color? Now, I'm picking random colors and it's just going to flicker endlessly. One way around that, just for demonstration purposes, is I can set a random seed before I go through that for loop to make sure all the colors are picked are always the same. Let's take out the stroke. Now you can see I've made this mask out of random colors. What if I were, instead of picking the colors randomly, I were to actually pull the pixel values from the underlying video itself? Probably it makes sense for me to get the color from the center of each triangle so I can quickly add up the x's, add up the y's, and divide by 3. Then I can get a color from the video at that x and y and fill with that color. Now you can see suddenly the frame rate has really dropped. So the get function is very convenient for pulling a pixel color from an image, but if I'm going to do it more than once, it's actually quite slow because it's loading all of the pixels into memory with every call to get. It would be much more efficient for me to load the pixels into memory just once. I can do that by saying video.load pixels at the beginning of draw. And then instead of get, I can look up directly into the pixels array. Uh-oh, I've really run into some trouble here. I've been using some single letter variable names, which generally is bad practice. I felt like that was pretty convenient for the 3 vertices of my triangle, A, B, C, but now I want to use R, G, and B for the red, green, blue values of the color. I can't use B twice. I don't love this, but I'm just going to use R, G, G, B, B. I'm getting something, but it's off. I realized I forgot something. So the reason why I love the get function is I could say, just get me this color at this X and Y. If I'm not using get, I need to figure out how to take my X and Y and convert it to the right spot in the pixel array. That's what this formula is doing. Take the X and Y, use floor to remove the decimal point, then calculate the individual index into that array. But I've forgotten that that array actually has 4 spots for every color. Red, green, blue, alpha. Red, green, blue, alpha. So index actually, in addition to being X plus Y times the width, has to also be multiplied by 4. There we go. If you want to learn more about the pixel array, I've covered this in more detail in many other videos, specifically the pixel array in P5.js 1. Hopefully, ideas are spinning in your head about other ways that you might choose to color or draw these triangles. Where I'd like to take this, and where I'd like to finish this video, is look at what it means to, instead of just filling each triangle with a single color, what if I were to texture map the pixels from another image onto this particular mesh? Here is where I need to now talk about the concept of UV coordinates. Remember, these triangles started with a collection of XY points, the key points of the FaceMesh model. They are inside of a larger P5 canvas. So this point here has a specific XY. Maybe it's something like at X is 400 and Y at 50. I'm creating this triangle out of 3 vertices. I say begin shape and end shape with 3 calls to vertex. I guess I should number these according to these index values. This is the code to render this particular triangle, and it would have any given stroke for the outline or fill for the interior color. But look at the way I wrote this. I didn't actually close the parentheses after the XY argument. This is because there is another set of coordinates that you can optionally pass into the vertex function, the UV coordinates. What are those coordinates? I didn't really think well about my whiteboard layout here, but I think I'm going to get there. Let's imagine I had another image, an image of anything. This is what is typically referred to as a texture. What if I wanted to take a specific section of that image? And I wanted to take whatever pixels were in that section, and I wanted to cut them out and map them, place them, stretch them, skew them, however I need to fit them into this triangle that I just drew. Well, I could specify 3 XYs from that textured image. That's what the U0, V0, U1, V1, U4, V4 are. This is called texture mapping. I've actually done this before in Coding Challenge 63, texturing a cloth simulation. Now, instead of texturing some simulation of a cloth waving in the wind, I want to take an image and texture it on top of my FaceMesh collection of triangles. Let's first do something very literal, which is actually take the pixels from the video image and texture map them onto this FaceMesh. I can get rid of everything now that's controlling the color of each triangle. There are only 2 steps to this. The first step is to call the texture function and pass in the image you want to texture. In this case, the video. I don't actually need load pixels anymore either. But there's an unfortunate error. Texture is only supported in WebGL mode. So in order for me to texture a shape, I've got to change the rendering engine to WebGL. That's as easy as adding another argument to create canvas. However, you'll notice the FaceMesh is now off at the bottom right-hand corner of the canvas. This is because WebGL considers the origin point to be the center of the canvas, not the top left. A quick thing that I can do just to adjust that is to add a translate call to the beginning of draw. Now my code behaves as before. You'll notice It's green. There is some kind of texture mapping going, but it's clearly not mapping it correctly. This is because I haven't actually added in the UV coordinates. What if the XY positions of where I'm drawing my mesh are exactly the XY positions in the source image that I want to texture? Well, then the UV coordinates and the XY coordinates are equal to each other. And look at that. Let's remove the stroke. And there we go. Now, interestingly enough, the eyes and mouth are cut out, so it's already a little bit spooky. So this is maybe not the most interesting result since it's just the literal image texture on top of the face mesh itself, but this could be a starting point for some creative possibilities. Maybe you move the points around in some way to stretch and skew the face. This allows you to overlay just this face on top of a different background image. Lots of possibilities. But what I want to look at is what does it mean to take another image that is not the raw source image and texture that onto the face. Let's try this Creative Commons licensed aerial photograph of clouds. I've uploaded it to the P5 web editor, so now I can load it in preload. Then I can just swap it out in the texture function. Now look at this. As I pan my face around, it's revealing the clouds underneath. That's because I'm using the raw pixel locations of the FaceMesh keypoints and mapping those directly as is onto the source image. What if I don't want to do that? Remember this image. What if I were to take this diagram of a generic face mesh and overlay it on top of this cloud's image? Regardless of where the actual key point detected on my face is, what if I were to look up the corresponding pixel in the cloud's image according to this fixed face mesh map? If I knew the XY position of every one of these key points on this fixed map, I could then use these fixed positions as the UV coordinates. This is what's called a UV map. And in fact, ML5 will give me this UV map. I'm going to add another global variable. I'm going to call it UV coords for UV coordinates. Just like I'm getting the triangles, I'm going to say UV coords equals face mesh get UV coords. Let's console log those. Notice how there's 468 of them. That is correct. I need a UV coordinate for every single key point on the face mesh model. But look at these. These are numbers between 0 and 1. They don't look like pixel coordinates. If this image were 400 by 400, the UV coordinate for maybe this top one should be X at 200 and maybe Y at like 40 or 50. The reason why the UV coordinates are not given in raw pixel values is because I want to be able to work with them with any image of any dimension. Having them normalized between 0 and 1 allows me to do that. It allows me to say I want this X coordinate at halfway inside of this image, or 1/4 of the way, 1/10 of the way, etc. Now currently, I am texture mapping with raw pixel coordinates, but there's a function in P5 called texture mode. The default texture mode is image, meaning work with the raw pixel coordinates, but I want to use normal for normalized coordinates. Now I can get those UV coordinates with each index value A, B, and C. Those are my coordinates UVA, UVB, UVC. Now, those points don't have an X and Y property. Instead, the X value is in index 0 and the Y value is in index 1. Get triangles, get UV coordinates, get skeleton, all of these functions in ML5 that are giving you information about the structure of the model that you're working with, they come in the form of arrays. So I can say UVA index 0 and UVA index 1, and the same for B and C. And there we go. Now I have those clouds mapped onto my face. Let's draw the video in the background just to see this as an overlay. I'm just curious what it looks like if the actual clouds texture is drawn in the background instead. Now, this is an arbitrary image that I just texture mapped onto the FaceMesh model. But what if I wanted to create a mask that had specific design elements for the nose and mouth and eyes? There are a variety of ways you could do this. Let's look at a kind of quick and dirty way of seeing if I can make this work. I'm going to go back into Photoshop. I'm going to remove this layer, and I'm going to create another layer. And I'm going to get the paintbrush tool, and I'm just going to start drawing onto the image. Upload it to the web editor, load that image instead, and there we go. Maybe I want to put the video back on. Now I have my mask overlay on top of me. There are my eyes in there, my teeth. That's very weird. I should mention that the model also does include an estimated Z position. So I'm not actually rendering this as a 3D shape, but that is technically possible. Let's add in those Z values. It looks the same, but you can see the plane of the video is actually cutting into it. Let's not draw the video. Looks the same, but I think now if I add orbit controls, I can change the perspective here. It's very creepy. All right, I've got to stop here. This video is much longer than I intended. Hopefully you're seeing a range of possibilities. If you make something with the ML5 FaceMesh model, please check the page on the Coding Train website, submit it to the Passenger Showcase. I'd love to see what kinds of creative explorations I missed in showing you how it works that you create. See you next time.